Yeah, hello, good evening. Welcome to KVS Guru channel. First of all, my sincere sorry, my sincere apologies to you because yesterday, due to some technical reasons, I couldn't take the class. Okay, so my sincere apologies to you. Right. So we are in number system. In previous classes, we discussed some number sets like the set of natural numbers, the set of whole numbers, set of integers, and the set of rational numbers, set of irrational numbers, and real numbers, and then complex numbers. All those we discussed in our previous classes. Not only that, what type of numbers are called rational numbers and what are the examples of irrational numbers and how to represent rational numbers on number line and how to represent irrational numbers on number line and we drew square root spiral also in previous classes and I gave you just like a homework to draw the square root spiral, right? Now today in this class let us discuss the points or the concept those are related to the decimal expansions of the real numbers. Okay, so here I'm writing the decimal expansion, decimal expansion of real numbers. Okay, so how to write real numbers in decimal form? Like this we will discuss in this class. Okay, now coming to real numbers, we have two categories in that in the real numbers. What are the two categories we have? One is rational numbers, one is rational numbers, and other one is irrational numbers. Irrational numbers. Now let us take first rational numbers. So how will be the decimal expansion of rational numbers? Let us see that one. So by taking some examples, let us examine the pattern of the decimal expansion of rational numbers. Okay, let me take one example first. Let me take like I will take one example like 5 by 8, suppose 5 by 8. So to convert this into decimal form, we have to divide 5 by 8. So let me do that. Okay, 8 we have, and I am dividing 5. So actually 5 will not go. That means 5 will not be divided directly by 8. So what we take is you take 0 point here and you put 0 here. Okay, then if you observe 8 times 6 is 48. Now, if you subtract 48 from 50, you will get 2. So take a 0, then 8 times 2 is 16. Yes, 8 times 2 is 16. So if you subtract, you will get 4. Right. Now you take another 0. That means 8 times 5 is 40. So here 5 by 8 I am writing here 5 by 8 equal to, we can write this one as 0.625. Okay. Right. Let me take one more example. Let me take one more example. I will take like something like 23 divided by 5. Let me take this. Okay, let us divide 23 by 5. Okay, so 5 times 4 is 20. We know that. I think all of you know how to do division, right? Okay, 5 times 4 is 20. If you subtract, you will get 3 here. Now, you can put point here and you put 0 here. So 5 times 6 is 30. So the remainder is 0. Okay, so here we can write 23 divided by 5 equal to 4.6. Let me take one more example. Something like we take 11 divided by 7. So let us divide 11 by 7. What happens? Let us check. If you are not comfortable with these type of notation, let me take like this. Let me take like this. Okay, 11 by 7 we need 7. You take like this. Okay, 7 times 1 is 7. Okay, remainder will be how much? 11 minus 7 is 4. Now you take point here, decimal point. So put 0 here, and then 7 times 5 is 35. Okay, 5 put 0. 7 times 7 is 49. 1 will be here. You take 10. 7 times 1 is 7. 3 will be 30. 7 times 4 is 28. 2 will be 7 times 2 is 14. Okay, 6 will be here, remainder 60. 7 times how much will be 60? 7 times 8 is 56. Okay, 4 will come. Now if you observe 4 here, you have to take 0 here. So from this, yeah, from this will be getting repeated, right? So you can stop here. Why? Because once again you will get 5 7 4 1, not 4 1 1 4 actually. Yeah, yeah, 5 7 1 4 2 8 and so on, like that we will get. So this block of digits, so 5 7 1 4 2 8, this string of digits, this block of digits getting repeated after this. So we can write 11 by 7 equal to 1.571428 and so on. This is symbolically can be written as 571428. All these digits we have to write under the bar. So this block of digits is getting repeated when we do 11 by 7. Alright, let me take the last example. Let me take the last example. Suppose you are dividing 20 by 3. Suppose. So what happens? Let us check. So 3. So 20. 3 times how much? 3 times 6 is 18. Okay. Now if you subtract 2, you will get, put point here, 0. 3 times 6 is 20. Again, sorry, 3 times 6 is 18. 3 times 6 is 18. So you take 2 here, 0. Again 3 times 6 is 18. 2 here, and so on. It will be getting repeated. So we can write, let me write here. Let me erase this and write here. So what is that? 20 by 3 equal to 6.6666 and so on. So you can write this one as 6.6 is under the bar. Okay, right. Now let us examine how the decimal expansions of these rational numbers. What here, if you observe here, these two values are, so when you perform the division operation, we got the remainder 0. So remainder 0 here. In the remaining two cases, we are not getting the remainder 0, but a block of numbers is getting repeated, right? So from that we can conclude that when you take the decimal expansion of rational numbers, that may be like getting remainder 0, or a block of or a string of numbers is getting repeated. Okay, so these type of numbers, like when remainder is equal to 0, these type of decimal numbers are said to be terminating decimal numbers. These are terminating decimal numbers. Terminating decimal numbers. The remaining two, these are called non-terminating, non-terminating, non-terminating decimal numbers. But in non-terminating decimal, these two non-terminating decimal numbers, a block of numbers, a block of digits is getting repeated. So we can say this one as non-terminating, repeating, or we can say recurring, repeating or recurring decimal numbers. Okay, like this, we have two types. One is terminating decimal numbers, other one is non-terminating repeating decimal numbers. All these are related to which one? Rational numbers. Okay, if we have rational numbers, we can write like this. So we can conclude one thing. Rational numbers will be either in the form of terminating decimal. That means we can write rational numbers either in the form of terminating decimal numbers or in the form of non-terminating repeating decimal numbers. Or if you take the converse of this one, converse means you go to reverse like this. That means if if you have a decimal number which is a terminating one, that means a terminating decimal number can be written as a fractional form, as a ratio form. That means that is a rational number. A terminating decimal number or non-repeating decimal, non-terminating and repeating decimal number. A terminating decimal number or non-terminating repeating decimal number can be written as a rational number, right? Like that we can conclude. From that, what can you conclude about irrational numbers? What can you conclude about irrational numbers? That means the decimal numbers other than this form are irrational numbers. That means non-terminating, non-recurring or non-repeating decimal numbers are irrational numbers. Okay, right. Now, up to now, we discussed how to write the fractional form in decimal form. But now, let us go to the concept that how to write the decimal numbers in fractional form. How to write decimal numbers in fraction form. Suppose we have 5.7. How to write this in fraction form? So this is very simple. Listen carefully. So this is equal to, first what we do is you just ignore the decimal point and you write the number first. That means you can write this one as 57 and then you write divided by, you put 1 here, then here we have one digit after the decimal point, just you put 10. Okay, that's it. This 5.7 equal to 57 divided by 10. How we got this one? That is very simple. If you take 5.7, you can write this one as 5.7 into 10 by 10. This is equal to 5.7 into 10 is nothing but 57 divided by 10. So without doing all these things, all these, we write directly like this. 5.7 equal to 57 by 10. So let me give one more example. Okay, suppose 423 point 423.56. Suppose we have, how to write this one in decimal form. So this is equal to, you ignore the decimal point. You ignore the decimal point. We have to convert this into fractional form, right? So you ignore this decimal point and you write like this. So this is 42,356. 42,356 divided by, you put 1 here. After the decimal point, how many digits we have? We have 2 digits. So just simply put 2 zeros. Of course, we can cancel this one. That is the other thing, cancellation and writing in simplest form. That is the other thing. But how to convert a decimal number into fraction form? Okay, this is how to do this one. Okay, hope you understand this. And now, one question arises. What is that means? Of course, here we have directly something like 4.26 or 5.3. We can write those directly into fractional form. But when we have, these are actually terminating decimal numbers, right? But if we have non-terminating decimal numbers, non-terminating and repeating decimal numbers, how to convert them in fractional form? Suppose if we take, let me take one example. Suppose we have 2.3 bar. 2.3 bar is for only 3. So how to convert this into fraction form? Actually, you have had the questions like this in your 8th class, right? So let us recall that. Okay, how to do this one? How to convert this into fraction form? So first, the basic method is first. Let me say the basic method. Then after that, just in a single step, how to write this in fraction form. That is a shortcut method. I will show you. I will explain the shortcut method also. First, let us take this one as x equal to x equal to 2.3 bar. So this is equal to x equal to 2.33333 and so on, like that we can write. Okay, right, understand? Now here under the bar we have how many digits? One digit. Under the bar we have one digit, so multiply both sides by 10. Multiply both sides by 10. Suppose under the bar we have two digits, we have to multiply both sides by 100. Suppose under the bar we have three digits, then we have to multiply both sides by 1000. So here what I am doing is I am multiplying this both sides by 10. So we will get 10x equal to 10 times 2.3333 and so on. So from this you can write 10x equal to here whenever you are multiplying a decimal number with multiple of 10, multiple of 10 means 10, 100, 1000, like that. If you are multiplying that multiplying a decimal number with 10, simply move the decimal point to right. But how many digits, how many zeros are there, you count. So there is one digit, there is one zero, so that is why you just move the decimal point to one digit right. So we can write this one as 23.3333 and so on. Okay, now what is x value? X value, this one 2 point, yeah, this is 2.3333 and so on. You can write any threes, no problem. You can write 4, you can write 5, how many threes are, that doesn't matter. Okay, now what you do is you subtract. You subtract. Okay, 10x minus x. If you take away x, 1x from 10x, you will get 9x is equal to, you subtract this one. So this is equal to 0, 0, 0, 0. 3 minus 2 is nothing but 1. So this is equal to 23 minus 2 means 21. 21.0000 means that is nothing but 21. So you can write 9x equal to 21. Right. So 9x equal to 21 means x equal to 21 by 9. X equal to 21 by 9. You can cross out, actually you can simplify this one. 3 times 3 this one, and 3 times 7 is this one. So this is equal to how much? 7 by 3. So actually this x equal to 7 by 3. What is x here? You see x is, you see here, this is 2.3 bar. So therefore 2.3 bar is equal to 7 by 3. Okay, like that we can convert a non-terminating or repeating decimal number into fractional form. Okay, right. So here one thing, is it correct? Let me check that one. Okay, that means 7 by 3, is it 2.3 bar or not? You may have a doubt. Okay, let us check. So here you can see a calculator, right? So let me take 7 divided by 3, that is equal to how much? Yeah, you see this 2.33333 and so on you will get. So clearly we can say 7 by 3 is equal to 2.3 bar, or 2.3 bar equal to 7 by 3. Okay, hope you understand this. Now let us take one more example. Suppose we have something like 2 point, let me take 2 point, yeah, okay, 2.34. Suppose there is yeah, 2, let me take 2.34 bar. So how to do this one? 2.34. Now the bar is for 3 and 4. So let us take this one as x equal to 2.34. Under the bar we have two digits. So under the bar we have two digits. Let us expand this one. 2.343434 and so on. Under the bar we have how many digits? Two digits. So we need to multiply both sides with how much? 100. So write 100 times x equal to 100 times 2.343434 and so on. Okay, go. So 100x equal to 100 times this one. Actually how many zeros here? We have two zeros. So just move this decimal point to two digits right. So it will become 234.34 3, 4, 3, 4 and so on. Okay, so 100x equal to this one. So from this, yeah, okay. So now what is x actually? X equal to, we know that x equal to how much? 2.343434 and so on. Okay, you subtract once again. If you subtract 100x minus x, how much? 99x. You have to take away 1x from 100x's. So that will be 99x. So you subtract this one also. 0, 0, 0, 0 point here. 4 minus 2 is 2. The remaining we will get 2, 3, 2. That means we can say 99x equal to 232. That means x equal to 232 divided by 99. Right. So now what is x actually? This one 2.34. 34 is under the bar. So we can write therefore 2.34 is equal to 2.34. For 34 we have bar is equal to 232 divided by 99. Okay, so this is the final answer. So we can convert 2.34 bar as 232 divided by 99 into fraction form. Hope you understand this one. So yeah, okay, let me take one more example. This is somewhat different situation. Suppose 54 point something like 2 5 7, only for 5 7 we have bar, only for 5 7 we have bar. How to do this one? Let us take this one as x. Okay, so our motto is to convert this into fractional form, right? So x equal to 54.257. For 57, the block of digits 5 7 we have bar. So let us take x equal to this one. So we can write x equal to 54.257. Then 5 7 5 7 5 7, like that 5 7 is getting repeated. Okay, now actually under the bar we have how many digits we have? We have 2 digits. So we need to multiply both sides by 100. So multiply both sides by 100. So 100x equal to 100x equal to 100 times 54.2575757 and so on. As usual, 100x equal to here we have 2 digits. So move this decimal point 2 digits right, like this. So this will be equal to 5425.75757 and so on you will get. Now what is x? What is x? X equal to this one, you see 54.25757 and so on, like that we can write. So now what we do? You subtract. Okay, if you subtract, what will you get? 100x minus x is how much? 99x. So write 99x equal to, subtract the right one carefully. So 7 minus 7 0, 5 minus 5 0, this is 0, this is 0. You see here 7 minus 2, this is 5. Point 5 minus 4 is 1. 2 minus 5, 5 will not go from 2, so take 1, borrow. So 12 minus 5 is 7, 3 will be here, 5 will be here, so 5 3. So we can say 99x equal to 5371.5, or we can say x equal to 5371.5 divided by 99. Okay, here again we have decimal point. So to remove this one, you multiply numerator and denominator by 10. So this will be equal to, so x equal to 53715. Okay, if you multiply 10, if you multiply a decimal number with 10, just move the decimal point 1 unit right, the 1 digit right. Okay, so you will get 53,715 divided by 99, and we have one 0, so 990. So of course we can, if there is any possibility to cancel, we can cancel, that is the other thing. But what is x here? 54.257 bar. Right, this is equal to 53,715 divided by 990. Okay, understand? This is how to convert non-terminating repeating decimal number into fractional form. Okay, right. This is somewhat longer method. Actually, we have some shortcut method for this one also. We have some shortcut method. Let me show you a shortcut method. Suppose 4.3 bar we have. 4.3 bar we have. We need to convert this into fractional form. Right. How to do this one means simply write 43. Simply write 43. Then observe the number which is not under the bar. We have what is that? 4. So take 4, subtract. If you subtract 43 minus 4 gives us how much? 39. Okay, so 39 divided by, after the bar how many digits we have? One digit. So you write just 10. Wait, sorry, 9, sorry, not 10, 9. Okay, so 39 divided by 9. Okay, so you can write this in simplest form, like 3 times 3 and 3 times 13. This is equal to 13 by 3. So you can write 13 by 3 equal to 4.3 bar. Okay, let us check whether this one is correct or not. 4.3 bar, we got how much? 13 by 3. Let us check by using the calculator. Okay, 13 divided by 3 equal to, you see, 4.33333 and so on you got. Okay, so let us take one more example. Let us take one more example. Suppose we have 37.245. Suppose we have 37.245. 245 is under the bar. 245 is under the bar. So what we have to do here? First, you take the number without the bars and these decimal points. So you'll get 37,245. Now subtract 37. Subtract 37. Why we need to subtract 37? We have to take the digits which are not under the bar. We have to take, right. So the digits which are not under the bar is 3 and 7. So I am subtracting 37. Okay, 5 minus 7 will not go. So take borrow. 15 minus 7 gives us 8. So here already from 4 1 went as borrow. So there will be 3. 3 minus 3 is 0. So 2, 7, 3. Right. So 37,208 divided by, under the bar how many digits we have? 3 digits. So you put 3 nines. Okay, 3 nines like this. That's it. Okay, this is the fractional form. Okay, let us check whether this is right or not. You see, 37,208 divided by 99. Let us check by using the calculator. Or is that, yeah, 37,208 divided by 999 equal to, what is that you got? You see, 37.245245. You see here 245. This block of numbers, this block of digits is getting repeated. So you can write this one as 37.245. 245 is under the bar. Okay, what we did actually, you see here, 37,208 divided by 999. Okay, this is how to convert a non-terminating repeating decimal into fractional form in shortcut method. But you may have one doubt. Okay, let me take one more example. Suppose, let me take one example. Suppose 7.23 and something like 6, 36 is under the bar. Suppose that means after the decimal point we have a digit we have a digit which is not under the bar, which is not under the bar. Now how to convert this? Okay, in shortcut form, that is what I am saying. So first what you write, as usual, you take the complete number without, that means ignoring decimal point and bar, all those things. Okay. So what will be that number? 7,236. 7,236. Our next step is, what is our next step? You subtract the digits which are not under the bar. Those are 7 and 2. Just you take 7 and 2. You ignore the decimal point. Okay. You need not to bother about that one. Okay. Now subtract. 6 minus 2 is 4. 3 minus 7. So will not go. So take 13. 13 minus 6, 7 is how much? 6. 1 will be here. 7 will be here. So 71. Okay, 7,164 divided by, how many digits are there under the bar? We have two digits. So you put two nines. Now for this digit which is not under the bar after the decimal point, we have this one 2. 2 is not under the bar, and this is after the decimal point. For that one, just you put 10. That's it. This is the answer. Okay. I will give one more example. Before that, let us check whether this one is correct or not. So 7,164 divided by 990. Okay. Let me erase all these things. How much is that? Wait, let me check. 7,164 divided by 7,164 divided by 990. Okay, this is what we have, equal to, you see here, if you observe this one, what is the block of digits is getting repeated here? What is the string of the digits is getting repeated? You observe carefully, 36, 36, 36, you see here, 36, 36, 36 and so on. So this is equal to nothing but 7.23636 is under the bar. Right, got it? So this is equal to what we did, you see here, 7,164 divided by 990. Hope you understand this. Okay, let me take one more example. Let me take one more example. Yeah, how to convert a non-terminating repeating decimal number into fractional form, like something like 14.6534534 is under the bar, like that you can take, or you can take 34 only, that's your wish. Okay, here I am taking this as an example. So what first step is, what is the first step? Ignore the decimal point, ignore the bar, and you write like 14,653,534. That means this is 1,46,534. That is the first step. After that, the next step is, what is that? You observe the digits which are not under the bar, whether those are after the decimal point, before the decimal point, that doesn't matter. Okay, 146 we have. So you write 146. Subtract. What will you get? 4 minus 6. It will not go. So you take 14. 14 minus 6. 14 minus 6 is nothing but 8. From 3, from 3, actually 1 gone as borrow. So there will be only 2. So 2 minus 4, it will not go. So take 12 minus 4, which is equal to 8. So here we will be having 4. So 4 minus 1 is 3. Here 6. Here 4. Here 1. What is the number we got? 146,388. 1,46,388. Okay, now you observe how many digits are there under the bar. Under the bar we have 3 digits. So you write 999. Now after the decimal point, you count how many digits are there which are not under the bar. After the decimal point, how many digits are there which are not under the bar? We have only one digit, that is 6. So that's why you put 10 here. That's it. So this one is equal to, yeah, this is the fractional form. Okay, let us check this one also. Actually, what is that we have? 146388. Okay, 146388. Okay, divided by 9990. This is what we have. This is equal to. Now you observe carefully. 14.6534534 you see 534, the block is getting repeated, you see this. So we can write this one as 14.6534. 534 is under the bar. This is equal to you have here 146388 divided by 9990. Okay, 1,46,388 divided by 9,990. Okay, got it? Yeah, this is, let me erase this. Hope you understand this. Right? Got it or not? Okay, right. So this is the decimal expansion of rational numbers. Now let us come to irrational numbers. Let us come to irrational numbers. The well-known irrational number we have is pi. We know that pi is an irrational number. Okay. Who found first the value of pi? So the Greek mathematician Archimedes, he was the first to compute the digits in the decimal expansion of pi. Who is that? Archimedes. Archimedes. He was the first person to compute the digits in the decimal expansion of the pi. Okay, he is a Greek mathematician. Okay, he is Archimedes. How he found, or actually he showed pi is in between 3.140845 and 3.142857. He found that pi value is in between these two. So we can write like this. Yeah, okay. Is less than pi is less than. Like this we can write. This was first found by Archimedes. Archimedes belongs to around I think 287 BC to 212 BC. Okay, he lived in this time. Okay, right. The famous Indian mathematician Aryabhatta, I think you know Aryabhatta. All of you know Aryabhatta, right? So famous, he was the famous Indian mathematician Aryabhatta. He showed or he computed the value of pi up to four decimal places. He found the value of pi as 3.1416. Okay, all right. This is about pi, the irrational number, well-known irrational number pi. So actually, we know that an irrational number that can't be written in p by q form. So what will be? How will be the decimal expansion? The decimal expansion of irrational number is non-terminating, non-repeating decimal number. Non-terminating, non-repeating. If you take the example like something like 4.3701254099 and so on. Okay, if you observe this one, there is no special pattern in this one. Moreover, this is a non-terminating decimal number, and no block or no string of digits is getting repeated in this one. So we can't write this one as a fractional fraction. Okay, we can't write this in fractional form. These type of numbers are nothing but irrational numbers. Okay, let me give one example. Suppose like something like 9.1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5 and so on. Is this a rational number or irrational number? Can you say it? Can you say? Is it a rational number or irrational number? Yeah, actually, you see, it looks like, it seems like the digits are getting repeated. It seems like that, but actually not. So here, if you observe, this is 1, then we have 1, 2, Then we have 1, 2, 3. So you observe the digits are not getting repeated. The pattern is getting repeated here in this one. So this is not a rational number. We can't write this in the form of a fraction, in the form of a ratio. So this is not a rational number. This is an irrational number. Okay. This is the decimal expansion of expansion of rational numbers and irrational numbers. That means the real numbers. Okay. Let's stop the class today. Okay. Before that, let us have a small simple quiz. Okay. Are you ready? Are you ready for the quiz? Yeah. Okay. Good. 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 Yeah. Okay. So the first one. First one. Uh, So 2.3 bar, 2.3 bar is equal to dash. 2.3 bar equal to dash. Here, yeah, okay, 2.3 bar equal to dash. Okay, and you write your answers, you type your answers. Okay, you type your answers. You send those in chat box. Okay, right. Okay, yeah, super. Let me say the answer for this one. So 2.3 bar, this can be written as 23 first, you write, and then subtract 2, you will get 21. Okay, 21, then divided by, under the bar we have one digit, so we put 19. I think I took this as example, right? Oh, okay, same thing I gave, okay, right, this is equal to actually 7 by 3, right? So let me give one more example. One more quiz question. Okay. So what is the decimal expansion of? Yeah. What is the decimal expansion of or decimal form? Decimal form of 432 divided by 100. This is equal to. Yeah. You say your answers. 432 divided by 100 equal to. Yes. You say your answers. Yeah. Okay. Yes, okay. The answer is actually 4.32. That's it. Actually, we have two digits and the two zeros actually in the denominator, right? So this is a multiple of 100. We have a multiple of 10, and we have two zeros. That is why you put a decimal point such that after the decimal point we must have two digits. That means 432. You can't from left to right to left actually. So 1, 2, so you put decimal point here. So 4.32 is the correct answer. Right. Let me give one more. So what is the fractional form of 57.42 42, let me take 2 under the bar, just 2 under the bar. Yes, you say the answer for this one. 57.42, 2 is under the bar, 2 is under the bar. Yeah, okay. Yeah, okay, right. Let me say the answer for this one. 57.42 we have, you ignore all those. 5,742. Now subtract 574 from this. So first 12 minus 4 gives us 8. Here we will be having 3. We have 3. So 3 minus 7, it will not go. So 13 minus 7, which is 6. Here 6 will be here. 6 minus 5 is 1, 5. So first you write 5168, then divided by how many digits are there under the bar? One digit. So you put 19. So then after the decimal point we have one digit which is not under the bar. So 5168 divided by 90. For this we put 10. That's it. So 5168 divided by 90. Okay, very good. The last question for today, that is, who computed First, the digits in the value of pi. Who computed the digits? Okay, the digits in the decimal expansion of pi. First, okay, who is that? Yeah, who is that? That is nothing but Archimedes. Okay, Archimedes, right. Okay, so I hope you enjoyed the class. Thank you very much. Let us close this for today. Tomorrow at the same time at 6 o'clock, right? Sharp at 6 o'clock in the evening. Tomorrow, let's continue this class. Okay. Thank you on the behalf of KVS Guru. Thank you. Thank you.